And that's really what this is about. If you really think about true sustainability, it's not just that, we kind of wave a flag and say that we're green. It also has to make business sense at the end of the day. And that's what will start changing a market.
Welcome to the Fine Homebuilding Pro Talk podcast, our regular discussion with industry professionals. Today I'm joined by engineer Paul Torcellini. He works for the National Renewable Energy Laboratory. You can find the Fine Homebuilding Pro Talk podcast and the regular Fine Homebuilding podcast at finehomebuilding.com/podcast. Paul, it is a pleasure to meet you. Thank you very much for being on the Pro Talk podcast.
Well, thanks for having me today.
Someone told me that I should talk to you, and I usually listen to my listeners because they're pretty smart people. Can you please tell me what you do at the National Renewable Energy Laboratory?
Sure. So I work in one of our commercial buildings research groups and focus on how to get commercial buildings to be very low energy. A lot of my work has focused around zero energy, zero carbon, and trying to hit that goal for buildings. And actually, kind of see that the meter is moving slower, right? We can talk about a lot of this stuff, but until meters start moving slower, we really haven't accomplished much. And so a lot of my research, I'd call it a lot of applied research, is focused on that.
And so was your engineering schooling dedicated to this subject, or is this something you've moved into during your career?
No, I think I'm one of the few people that I know that has always wanted to study buildings and work with buildings. I kind of fell in love with it even in junior high school and moving into high school. At the time, the high school I went to we kind of had just gone through the second oil embargo, and oil was very expensive, and oil was used as a heating fuel. And they were cutting programs left and right because they couldn't afford that, like athletic programs and things, and I was never really an athlete in that sense, but I got interested in saying, well, how can I contribute to that? And basically self-learned how to do energy audits in my high school and took that information, to the administration and said, look, if you get rid of these incandescent lights lighting classrooms, you could save, hundreds of dollars a year. And at that time moving to fluorescent, or, if you added a little insulation, here's what it could do. And, at that time I had calculated the numbers and, came up with the arguments even then. So when I was ready to go to college, I was like, how do I, do this and continue to do this? And so really focused my education way before people thought about, like architectural engineering programs and things that focus on it. I basically was a crossover between a mechanical engineer and an electrical engineer to learn these technologies to do this.
That's fascinating. Did you get any traction with your school district with regard to energy improvements in their buildings?
I got a little bit. I think I probably gained more knowledge than they got benefit at the end of the day. But, I think it really was a start. It was an era where people really weren't thinking about that. And so this notion that you could save a lot of energy, or maybe that we were just wasting energy, people really didn't think about it or appreciate it at that time.
Can you tell me more about the National Renewable Energy Laboratory? I suspect they have a number of goals, but primarily what is their job?
So the National Renewable Energy Lab is the easiest way to say it is kind of part of the U.S. Department of Energy. We're actually a government-owned laboratory, much like there are many DOE national labs. We are the only national lab that has solely an energy efficiency and renewable energy focus. A lot of the other ones are much broader in their missions, have a much broader kind of science mission. Ours is focused just to that. So when you look around the laboratory, obviously we do buildings research, but we also do, a lot of automotive research and comfort in autos and moving to electric vehicles, a lot of work in biofuels. We've got a very large group that studies photovoltaic panels, all the way from kind of the physics and the chemistry that goes into really tiny panels and increasing their efficiency, or little cells, all the way up to how do you manufacture and deploy those for less cost. We have a very large wind technology facility that looks at, the design of wind turbine blades, what might cause them to fail. How do you take those large scale renewable power inputs and put them onto the utility grid? How do you increase renewable penetration, right? Think of all of the kind of tough questions around moving to renewables and reducing energy consumption. And the lab is probably thinking about those.
Interesting. And where is it located physically?
So physically, the main campus of the lab is in Golden, Colorado. We do have a wind technology center that's located a little bit north of that near Boulder, Colorado.
And I'm guessing COVID has mixed things up for you guys like it has for everyone. Has your work been affected?
So different pieces of it are, certainly at the beginning of COVID, everybody went remote, which really kind of slowed down a lot of the laboratory research. A lot of our building science research, a lot of modeling and a lot of kind of analysis that goes on. Very little of that was impacted because people moved all their stuff remote. We've got the same tools to communicate back and forth remotely as others do. Access to our supercomputers and things can be done remotely. So it definitely had an impact. But I think we've done a pretty good job at kind of maneuvering through that and keeping our focus on, the world of renewable energy and energy efficiency.
Wow. It's fascinating work. I love it. How did you mentioned that you had this interest spawn from the oil embargo in the 70s, right? Did you have people that you especially looked up to or influenced your career at that time period?
Yeah, there were several people that I would kind of say started me on that track. I went to a very small school, elementary school, and the sixth grade teacher, who was very big into math and science, encouraged me to kind of think about just energy. And he handed me a book, and I was always off doing little projects and things anyhow. And I think the name of the book was something like Fun in the Sun. And it was a book about building little solar toys and things. And so one of the things I did was I got cardboard and aluminum foil and made a 4-foot dish that was a reflector that we could cook hot dogs with. That went.
How long does that take, if I can ask?
What's that?
How long does that take?
To cook a hot dog?
Yeah.
Oh, well, if you've got a good sunny day and you put it right in the center of the hot spot, you can make crispy hot dogs in a matter of minutes if you want to.
Awesome.
So yeah, no, it's pretty impressive, when you start concentrating the sun like that, how much heat you can generate. But that really started me on this kind of love for, some of it is kind of an independence, right? It was something that I could do. This notion that I could create energy and use energy without, other means was fascinating to me, and always was fascinating to me.
How about high school teachers? Any that were in the sciences or math field that you found especially good?
Yeah, so I think they were very much encouragers in that. I had a couple of teachers that encouraged me to learn how to use, at that time, the school's mainframe computer. And that was actually what I learned how to program on initially, with punch cards, if anybody knows what punch cards are still, and actually wrote the programs that we used to analyze that campus's energy use. And so, they encouraged me to do that. I think I was definitely thinking about things that they hadn't thought about. So, having that encouragement really worked. They also hooked me up with, at that time, the energy office with the state of Connecticut, and a couple of other schools around the state that were thinking about energy efficiency. And that was part of where I started learning some of this. That then hooked me up with a brand new organization. It was called the Need Project. And that organization really was focused on educating high school students at that time to be energy leaders for the future. and it was the National Energy Education Day. It later became the National Energy Education Development Project. They're still around, educating students on, the needs and what can be done on energy efficiency. And a lot of it is just general energy education, that people are not aware of just how much energy impacts our lives every day. Most people don't kind of see those things.
In what ways, Paul? How are we missing that?
So, just the whole notion that, what is it? 80% or so of the worldwide energy is fossil fuels. And, that is a limited supply. It has an impact on the environment, and that is, many facets. We talk about climate, we talk about, water and air quality. It gets involved in kind of politics and national security. I mean, it is just involved in everything we do in our lives. I mean, think of, what would you do if you didn't have fossil fuels available to you today, right? And just, the first part is an awareness of those things, right? Because without that, it's really hard to think about how are you going to shift to something else and make those connections.
So your recent work is focused on making commercial buildings as close to net zero energy as possible. Can you explain what that means to folks who might not be familiar with the concept of net zero energy?
Sure. And so there's, it's interesting. People are very passionate about what they call it. Sometimes it's net zero, sometimes it's zero net, sometimes it's just zero. That's kind of an interesting discussion. But fundamentally, it's about a balance, right? That, buildings, stand outside of your house and look at your house and you say, is my house a polluter? Right. And when you look at that and you say, well, it doesn't look like it's polluting. When you talk about pollution, the first thing that comes to mind is usually tailpipe emissions out of a car. Right. Well, at the end of the day, there are more emissions that come out of buildings than our transportation sector.
Right? From combustion appliances or in the electricity generation to power them?
Both pieces of it. Right. And so and part of the reason it's not relevant is you don't really see it. Right. So in some ways, it's easier to talk about in the auto industry because you see stuff coming out of your tailpipe, and periodically you go to a gas station, you physically put in fuel, you physically see the numbers on the dial turning, right, and you have a connection to that. People don't go out and watch their energy meter on the outside of the house. Right?
I do.
I do too. Going back to high school, I used to read the electric meter on my parents' house every day, and I reported back.
I bet they love that.
Yeah, I get questions like, "Well, then I won't bake you any more cookies," kind of thing. But it's really that direct connection. And because electricity comes from afar, we really don't always see that. We don't, know that that's an issue. And even bringing in, say, natural gas to a house. You get a bill once a month, and it's kind of in back time. And so it's hard to relate that back to, the actual impact of that energy.
I think most people would agree that energy is still very inexpensive in this country. I think when you and I were growing up and going to grade school or middle school or whatever, we assumed that we would have to switch because we would run out of fossil fuels, right? I think that was the discussion because of the scarcity associated with the oil embargo, right? But the problem has emerged that it's the burning of the fossil fuels that's going to warm the planet and affect its climate. Was that realization there for you as a younger person? Did you know that the problem was going to be carbon emissions versus scarcity?
No, I don't think we've really, kind of whole stream talked about that until fairly recently. I think I've always been aware that it's, there's a lot of reasons over time, right? I mean, like I said, I got into it initially because people complained about the price.
Yeah.
Right. And then you start digging into it and you start learning more about it, and you realize, that there's a lot of environmental damage just in, smog and, at that time, acid rain, from sulfur emissions. Right. So we kind of addressed a big fraction of that. There was, just direct emissions. So smog, there was water quality issues. Obviously, when we talk about the oil embargoes, there were political sensitivities, that went with those things. Um, Obviously, the larger, kind of carbon emissions, has always been out there. But I think it's not until, fairly recently that kind of has hit the mainstream as, one of the major factors.
I have trouble imagining a world without fossil fuels, and I'm sure a lot of folks do. What is it going to be like? Will we have big batteries in our houses? Will our cars be connected to the grid? How's this going
Yeah,
to work? Because renewables are great when they're working, but I think you'd agree that there are times of the day or the year that they don't work, right?
yeah. So, there's different pieces of that, and I'm not sure my crystal ball is any better than yours, right? In trying to predict exactly what that's going to look like in terms of, where do those technologies, go, which ones start to dominate and happen. As I focus on buildings, and I don't think we fully answered kind of the zero energy question for you there, but that's really about balance, right? So at the end of the day, one of the ways I like to think about it is, as we sit on our piece of land, that our building or our house sits on. Let's just look at the house for a minute. You know, there's sun that comes to that house, right? That's our renewable resource. That's the resource that is really available to us, you know, and there's not much else available. So take it at that scale to start with, right? So how do I get my house to only use as much energy as the sun that's coming to me? Right. And so the only way to really do that is with some pretty aggressive energy efficiency. Right. So I have to think first about using less. Right. And then once I use less, the question is now, how do I start collecting that solar energy? Right.
A
And I,
surplus for evening, right?
right. Right. Well, just on kind of a gross scale, how do I even think about it conceptually, making that match? Right. And then the next question is how do I store it? And what does storage look like? And again, there's a big area of the lab that is focused and thinking about energy storage. Um, Storage comes in lots of different forms. I mean, I think people think about batteries, but things like, the hot water tank that stores energy for your showers. Right? I can set up I've got this little heat pump hot water heater at my house, which is, pretty close to zero energy. And I can actually tell that heat pump hot water heater to only run when the sun is out, or during the day, store that into a tank. And that actually would give me probably about a 2-day supply of hot water at the end of the day. Right. So I can start thinking about what we call alignment of resources. Right. It doesn't have to be a battery. Right. I've got that tank. There's other things. And if you talk to people who, what I would say, live off the grid, so I am grid connected, but there are people that live off the grid that have battery storage, have photovoltaics, have very energy efficient houses, and then they say, okay, what are my storage mechanisms? Right? We talked about hot water. Even I have friends that do this, and they even say things like, "Well, we tend," and this is probably a little on the edge, right, for most people today, but they're early adopters. They say, "Well, I do laundry on sunny days." Right? Because I have a lot of hot water, I've got the electricity, and I've got the sun to dry my clothes. Right? And they plan things. I do my vacuuming on sunny days because that's an energy source, right? A clean house, clean dishes are in some ways a form of stored energy. And people do think about that. Most people are not ready for that. I think that is probably not going to hit the mainstream. And as the price of batteries come down, as we think about other storage mechanisms, as we do a better job at insulating our houses and buildings, those things will all come together to really, think about that zero energy world.
I have.
I'm sorry, and that's really about this balance, right? That a building, instead of being a consumer of energy, now starts being a producer of energy, and that's really the concept that we're going towards.
I, currently, commercial buildings, the utility costs are shifted to the tenants, right? So people who build commercial buildings have little incentive to make them energy efficient, right? Is that an oversimplification?
So there are lots of different business models, right, that go with that. Yeah, you've talked about one. Certainly, a lot of the early adopters of highly energy efficient buildings. So, like NREL has, I always claim that it's the largest zero energy building in the world. Nobody has challenged me yet on that, but that building's been running for about 10 to 12 years now, and we produce as much energy on site as that building consumes. And that building uses one half the energy of a typical office building. But we own that building, we occupy that building, right? And so we have a vested interest, a long-term interest in that, in the energy savings, in the mission of doing that. One of the things that I'm starting to see shift in kind of the model that you're talking about is this notion of companies making proclamations that they want to be carbon neutral. And what does that mean, right? Well, if I build a building and I don't enable my tenants to have the ability to be carbon neutral, then I, as the owner of that building, have some responsibility to that. And we're seeing a lot more interest and thinking around that. Likewise, the tenants of these buildings want to have, are also coming up with a lot of these goals and sustainability goals. And so they're starting to look for buildings where they can kind of fit in, and it will help their environmental goals corporately as well.
Do you think we should be incentivizing building owners and building developers to be making better, more efficient buildings?
So I think that the question of incentives is always very interesting. The first part is, I think in order to solve kind of this energy discussion, it's a very broad problem and everybody needs to be involved, right? So we all have some ability to make decisions. We all have some kind of control, some what I call span and control of those decisions. And everybody has a different span and control. And in order to kind of make a wholesale change, we all need to be thinking about it at every level, right? And what can we do? So if that means, setting up, incentive programs at many levels, if it means that a state wants to set up a state policy and use money through that policy to have utilities incentivize consumers, those are all, market mechanisms, especially to bring product to market. Ultimately, and the reason that is that when you introduce new product and new ideas into the marketplace, it usually costs a little extra money. Mm-hmm. But we've gotten to the point now, and again, the National Lab exists to really think about something like photovoltaics. And just as an example, the cost of photovoltaics has dropped something like 90% in the last 10 to 20 years. I mean, it has gotten to be so inexpensive that what we're seeing now is that if you want to put photovoltaics on an energy efficient building, it's like less than 1 or 2% of the total building cost, right? And it's gotten to be so small that there are many people that are willing to either finance that or direct finance it through the company. It almost doesn't make sense not to put solar panels on your building today, because it's gotten so inexpensive and so competitive with the rest of the market. At that point, the market will recognize where the business opportunities are, right? And that's really what this is about. If you really think about true sustainability, it's not just that, we kind of wave a flag and say that we're green. It also has to make business sense at the end of the day. And that's what will start changing a market.
You mentioned one of the things that I want to ask you about, but in our initial correspondence by email, you said, I really try to stress that we all make decisions every day that have energy and environmental consequences. You mentioned that you don't think about the energy your house is using because you don't see it being consumed like you do, the exhaust vapors from your vehicle. What are some of the other things that we should be paying more attention to?
Well, think about every decision that you make, right? Like, did you have a cup of coffee this morning?
I did.
Right? Was that in a ceramic mug or a paper cup?
It was in a ceramic mug with dioxins on it.
All right. right? So, so then, you've got a product that you've reused. It probably has a fair amount of embodied energy, which means you need to use it a lot of times to have it make sense, right? And to your credit, you're not using something that you're going to immediately throw away, right? As opposed to saying a paper cup that you're putting it in. And those are all, consciously or not, those are all decisions that you make, right? You can start talking about where was that coffee sourced? How did it get to you? Right?
You're going to make me depressed, Paul.
But that's where it goes back to every decision that we make, right? Do you use recycled paper in your photocopier, in your home office kind of thing, right? Those are all decisions that you directly make that have an impact.
How do folks like us, though, really know what the better energy choice is? Do we really know that using recycled paper is better as from an energy perspective than it is to use new paper, for example?
Yeah, so there is a whole science around, embodied carbon and, what the best pathways are. It only makes sense if, how well can you kind of recycle that paper? Where does it come from? I once was looking at a package of paper that was recycled, and I was like, oh, this is interesting. It's recycled. And then it was wrapped in a plastic wrapper, which I kind of questioned. And then I looked a little closer, and the paper was made in Australia, which meant it somehow got shipped to the United States. And those become very tough, complicated questions. There are some easier ones like, setting your printer to duplex, print on both sides of the paper, right? So I think there's some simple, clearer ones, lowering your thermostat, building a more energy efficient house.
These things must keep you up at night, right? I mean, like, how does an engineer sleep thinking about these questions?
Yeah, well, how much I had one of my program managers one day says, commercial buildings consume 17% of the nation's energy. What are you doing about it? Right. But, what we do about it is, spend a lot of time talking about it, doing research, showing good business pathways. I recently did a research project on the cost of zero energy K-12 schools. And at the end of the day, we found no correlation between the cost of building a new school and how much energy it consumed. Right.
So it costs the same to build a high school that uses a lot of energy versus one that doesn't. Am I understanding that correctly?
That is the understanding, right? And I think you can start applying that to other building types, right? Now, what's stopping us, right? It's know-how. It's a long-term belief that energy efficiency has to cost more money, right? Even take something like my house. I spent a lot of extra money on like the walls and the insulation and getting the house good and tight. And then I didn't spend a lot of money on the heating and cooling system at the end of the day, right? And so, you can, spend money in one place and save it in another. I had a school designer tell me that if they spent, and it was something like an extra $400,000 on the envelope, they could save $500,000 on the size and the installation of the heating and cooling system. Right? But you have to kind of think about it in that what I'd say holistic way, right? I think one of the challenges with buildings is that we build them out of lots and lots of little pieces that show up.
And you have individual experts, right? You have an engineer who designs the heating and cooling system. You have another engineer who designs the structural elements. I don't know that anyone is thinking about it holistically in those kind of projects. Am I wrong about that?
There are some design teams that have really taken on that challenge, right? And they will design to energy design goals. One of the pieces of work we did was established energy design goals for energy. I guess I said that twice. Energy goals for K-12 schools, right? And so you can look at what climate you're in, and we can give you a target. And between the owner and your design team, you could say, yep, that's the target I need to be at, right? That's the same thing with doing zero energy, right? If you're, a home builder or a consumer, and you're like, I want one of these, the good thing is there are lots of examples out there. It might not be mainstream, but it's clearly now far from some unusual niche market. I know. Then there were funny things that went on over the years, like this notion of living underground was going to save the world, right, in the 1970s. And you don't need to do that today. That we've advanced the technologies around the building sciences so that we can build these houses, we can build these buildings today at a price that makes sense.
One of the things that one of my former colleagues said to me one time is he was on the local school board, and they were considering building a new school. And because of the ventilation rates associated with modern schools, and probably for good reason, especially we see that now, that the energy costs are actually higher than they used to be. Is that true?
So, yeah, it's interesting. And there are lots of stories where people either took down an old school, a replacement of a school, built a new school. They saw their energy go up and they're like, how can that be? I would classify that as something I call level of service. So the old school may not have had air conditioning. It may have just been, heating and some operable windows. And maybe the air quality was, marginal in that building. And when they replaced it, they increased the ventilation air. They added air conditioning. A lot of times we see when people build a new building, everybody wants to be in that building. So suddenly this building is used nights and weekends because it's a nice space, right? They have a nice new gym, right? And so a lot of times we do see that energy impact go up in new buildings. Now, the catch is that we can still do it, and again, these very high performance buildings where we can do heat recovery, we can use, ground source heat pumps to provide heating and cooling. There are definitely a lot of strategies we can use to get that down to a pretty low level and maintain the air quality. I think we will see some design changes, with COVID and air quality, moving forward. I do not see that as being insurmountable in, still achieving these zero energy goals.
Well, unfortunately, that is all the time we have for today. Thanks very much for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. That helps other folks find our podcast. Stay safe, everybody, and thanks for listening. Tune in next week to hear the second half of my interview with engineer Paul Torcellini.